Scatter plots, they're just a representation of data on a graph. They are called scatter plots because it's kind of looks like dots are scattered across there. All right. When you're making one, you can use a graph like this. For these, I would make my own. Okay. I would ignore the x and y axis, and I'd make my own. I'd say this right here is my y-axis, and this right here is my x. Okay, it gives me the whole graph to work with. Okay, I have a lot more lines to work with, right? Yeah. Than if I only used this one. Okay, that would be a little hard to work with, right? Yeah. Okay, trying to get all these numbers squished into 10 lines, 10 by 10. Here, I have 20 by 20, a lot more room to work with. Okay, so I'm going to go 1940 right here, 1950, 1960, 70, 80, 90, 2000. Okay, I can't write with my finger, so you should just write like 1940 there. Okay, that's our X. Okay, this is our Y. My population, I'm going to go 100, and then I'm going to go by 20s. No, let's go by 10s. So 100 here, okay, 10, 20, 30, 40, 50, 60, 70, 80, 100. All right, so that's 200 right here, 10, 20, 30, 40, all the way to 300 right here. Okay, and then all we do is we graph it. So 1940 is at 108. Population is 108. So it's just barely above 100 right there. Okay, 1950 was 125. So in between the 2 and 3, right there, a little bit taller. Okay, 1960s, 275. It exploded that year and went all the way up to about there. Okay. And then 1970 was a little bit more. So for 1970 we had 278. 1980 it took a hit, it went down. So right in there, okay, doesn't have to be perfect, okay, but it needs to be kind of close. 1990, it went back up. And then 2000, it went up even more. Okay, if you look at population of Tampa, okay, between 1950 and 1960, it more than doubled, okay. Big increase there. Okay, the scatter plot lets us see that data. Okay. All right, what you need to do is write this down. Types of relationship, positive, negative, no relationship. Relationships. We have a positive relationship. Okay. This is where, as X gets bigger, my Y gets bigger. So if I've got a bunch of random dots, you can clearly see a pattern here. Okay, and we use a best of fit line to describe it. It goes right down the middle of them. It's like the average. This is a positive relationship. As X gets bigger, Y gets bigger. This would be like the time spent practicing a sport versus how good you are. The more time you spend practicing, the better you're going to get, right? Yeah. Okay? If you don't spend any time practicing, are you going to be good? Nope. No. So as your X gets bigger, your Y gets bigger. Okay? They affect each other in a positive way. Negative relationship. Is as X gets bigger or Y gets smaller. Okay, it goes down and to the right. This is a negative relationship, such as time spent playing video games versus test scores. Okay, if I don't spend very much time playing video games, what my test scores are going to look like?
Good.
Good, up here. Okay, if I spend a lot of time playing video games, what's going to happen to my test scores? They're going to go down. This is a negative relationship. So as x gets bigger, y gets smaller. No relationship. Okay, there is no pattern here. Okay, it would be maybe eye color versus age. Does your eye color affect your age? No. Okay, so there's no discernible pattern there. Okay, any questions on positive, negative, or no? All right, you need to draw this graph. All right, so let's talk about this. Okay, as my study time gets bigger, what's going to happen to my scores?
Better.
Okay, so if I have a low study time, I have a low score. If I have a higher study time, I have higher scores. Everybody agree?
Yeah.
Okay, what type of relationship is this? Positive. Okay, as study time gets bigger, scores get better. Here's your homework.